everyone. Welcome to the TDWI webinar program. I'm Brenda Woodbridge, and I'll be your moderator. For today's program, we're going to talk about MLOps and optimizing ML operations, learning from those who have been there. Our sponsor today is LTI. For our presentations today, first we'll hear from Fern Halper with TDWI. After Fern speaks, we will have a roundtable discussion and be joined by Shivanand Pawar with LTI, Ankita Gupta with Standard Chartered Bank, and Sanjithraj Rao with Otis. But before I turn over the time to our speakers, I'd like to go over a few basics. Today's webinar will be about an hour long. At the end of the presentation, our speakers will host a question and answer period with the audience. If at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, click on the Help area located below the slide window and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweet. Finally, if you'd like a copy of today's presentation, use the Click Here for a PDF line there on the left middle of your console. In addition, we are recording today's event and we'll be emailing you a link to an archived version so you can view the presentation again later if you'd like, or feel free to share it with a colleague. So once again, today we're going to talk about MLOps and optimizing ML operations, learning from those who have been there. Our first speaker today is Fern Halper. Well known in the analytics community, Fern has published hundreds of articles, research reports, speeches, and webinars on data mining and information technology during the past 20 years. Fern is also co-author of several dummies books on cloud computing, the hybrid cloud, and big data. At TDWI, she focuses on advanced analytics, including predictive analytics, social media analysis, text analytics, cloud computing, and big data analytics approaches. She has been a partner at industry analyst firm Hurwitz and Associates and a lead analyst for Bell Labs. Her PhD is from Texas A&M University. Fern, I'll go ahead and turn things over to you now.
Great, thanks Brenda, and hi everyone, and thanks for taking the time out to join us today on this panel discussion on MLOps. It's an important topic and one our audience is asking a lot about. So this is what we're going to do. First, I'm going to just spend a few minutes discussing what MLOps is all about and what we're seeing at TDWI in the way of MLOps. After that, we're going to go into our panel discussion with LTI, Otis Elevator, and Standard Chartered Bank and hear what they're doing with MLOps. I'm excited to hear from them. We'll also have time for Q&A, so make sure to be thinking about your questions. So let's just level set and talk about what machine learning is. It grew out of computational science. And here, you can see my definition here. It's where systems learn from data to identify patterns with minimal human intervention. And two popular ways of approaching machine learning are using either supervised or unsupervised approaches. You may hear that term. In the supervised approach, the system is given a group of observations with known outcomes or targets of interest, and then the system trains using those known outcomes, hence the name supervised. And then in unsupervised approaches, there are no outcomes provided. There are other approaches too, but these are two of the popular ones. And you can see I've listed here some common examples of machine learning, include things like churn, like maybe you're trying to predict churn or no churn, fraud, image identification using deep learning. At TDWI, we see that machine learning is being used across the organization. We see IT and operations are often at the top of the list, but it's being used everywhere, even in HR. If you think about predictive maintenance, for example, as a use case in IT or operations, but it's being used in customer service, marketing, and as I was saying, even in HR for employee retention types of use cases. Now, there's building the model, and then there's putting that model into production. And you could see at the bottom of the page here, I have machine learning ops, ML ops. So we're defining ML ops as practices and technologies to deploy and maintain machine learning models in production. And there's going to be people, processes, and technology aspects to MLOps. And that's what we're going to talk about today, MLOps. So here's a diagram, a TDWI diagram about the life cycle of machine learning efforts. So, what is this life cycle all about? I've divided it into 3 different sections. You could see something called ML prep, ML building, and then ML ops. So the ML prep, or the preparation part of the machine learning lifecycle, includes things like model formulation, so thinking through what the model is trying to predict. It's going to include identifying data to use to train the model, collecting that data, preparing that data, and assembling the data pipeline. Then there's the model building phase, and that's all about building the actual machine learning model. So this is going to include things like feature engineering. Feature engineering involves constructing new derivative attributes that can represent the problem to be solved. So you're going to take your raw data and transform it into something meaningful, something that's clearer than what's available perhaps in the raw data. So features can be fairly straightforward, things like a ratio, or they can be more complex, like a customer loyalty score. And we hear from data scientists, of course, that they spend a lot of time developing features, and they would argue that feature engineering is part art and part science, and then, of course, the model building process involves training the model and testing the model and tuning the model. But, we're here to talk about ML ops, which is the last phase, which is about operationalizing the models. And so this is the back-end deployment process that some organizations, I think, don't think enough about when they embark on a machine learning effort. But it's critical. If you can't put the model into production and you can't monitor it in production and know that you're working with the right model, know if that model gets stale, and be able to retrain it, then you're not going to get the full value from that model. So the MLOps piece of it, which I've highlighted here in purple, includes from our perspective things like validating that the model is going to work in an operational environment, deploying the model and, using whatever framework to deploy the model. We see organizations using containers to deploy models more often. It includes things like model monitoring, so models, depending on the model, models can get stale. So you want to be able to monitor the model, that's in production. And then if the model starts to get stale, you have to be able to retrain that model and put it back into production. And of course, I included here that it includes culture and processes for accepting the model, once it's in production. So that's basically the machine learning lifecycle. As I said, we're going to focus on the ML ops piece. And of course, it's all underlined by governance, because that's important throughout the whole machine learning process. So what we see is that at TDWI, we see that demand for machine learning continues to grow. So for instance, in a 2021 survey, over 70% of the respondents said that demand for machine learning was increasing. And we've seen that year over year. It just continues, there continues to be strong demand. And here in this 2021 survey, we asked, what are your company's biggest priorities for analytics in 2021? And people could select a maximum of 4 responses. And you could see at the top, that self-service analytics, that's close to 50%. So organizations are really interested in self-service analytics, and concurrent with that is building data literacy in the organization to make self-service analytics work. Of course, building literacy also has to do with other types of analytics, including machine learning. And you could see that number 3 on the list, and I boxed it off in red there, is upskilling business analysts to perform more advanced analytics like machine learning. And what we see is that, there's a demand for it. Organizations are trying to figure out who can, build these models. Do they have to hire data scientists? Can they upskill their business analysts? So that's why that one's pretty high. You could see utilizing machine learning, but then, down in sort of towards the middle of the chart there at about 21 or 22%, we have building a data ops, DevOps team for putting models into production, or it could be the MLOps team. In this question, we called it DevOps. So organizations are starting, I would say that organizations are starting to, pay attention to having to put machine learning models into production. Especially, they're going to have to be able to deal with this as they start to scale the number of models that they have in production. We see often that organizations may have between 2 and 5 models in production, but then and maybe they can manage that manually, but then as they start to scale the number that they have in production, they need to be thinking more about the people, processes, and technology around MLOps. So those are my introductory comments. I'm going to hand it back over to Brenda to introduce our 3 panelists, and then we'll get started with the panel discussion. So Brenda, back over to you.
Great. Thank you very much, Fern. And just a really quick reminder to our audience as we go through this panel discussion, if you have any questions for any of our panelists or Fern, feel free to enter them at any time in the Ask a Question window, and we will get to those questions right after the panel discussion. So without further ado, I'm pleased to introduce our 3 panelists for today's webinar. First, we have Shivanand Pawar with LTI. Shiva is the product head for Mosaic AI, a proprietary AI platform by LTI. With 10+ years of experience, he is a hands-on expert in data science, big data, Kubernetes, and application development. Shiva is actively involved in consulting with clients across various domains and adopting big data and machine learning and operationalizing AI ML at scale. He brings in immense knowledge around the challenges of machine learning adoption and how a systematic approach simplifies the journey and assures ROI. Welcome. And next, we have Ankita Gupta with Standard Chartered Bank. Ankita heads the IFRS 9 and Enterprise Risk Management technology domain for the bank and is known for driving innovation, digital transformation, maximizing operational excellence, and delivering financial performances to identify, evaluate, mitigate, and monitor the company's enterprise risk. Before her current role, Ankita has worked in a similar capacity at various other technology domains within Standard Chartered, such as GRC and liquidity. She has been an avid contributor to the Diversity Inclusion Index for the organization and runs various initiatives supporting the company's D&I agenda. After studying information technology at UP Technical University from India, Ankita worked with Fortune 500 companies, which opened new avenues for her in terms of professional growth and identifying her interests in enabling next-generation technology solutions and enablement. She is currently based in Singapore. Welcome, Ankita. And our third panelist today is Sanjithraj Rao with Otis Worldwide Corporation. Sanjit is the development lead and digital product owner of several pillars of the Otis One program, Otis's IoT connected elevator program. He is also a data architect and serves as an advisor to the Otis One Architects Group. He has been involved with ML and MLOps for the duration of his time at Otis. He filed for his first patent recently in the area of IoT data simulation and validation. Once again, welcome to all of our panelists, and I'll turn it back over to you now, Fern.
Great, thanks. This is going to be a great roundtable with a lot of good practical experience. So let's dive right in. Let's see. So I talked about, some of the popular types of models that organizations are putting into production. My first question is, can you tell us a little about each of your organizations and the kinds of models that you're putting into production, and also what drove the need for MLOps? So let's start with Sanjit from Otis. If you could lead us off on this, That would be great.
Sure. As you know, Otis Elevators is one of the world's leading elevator manufacturers. We have about 2.1 million elevators in service right now, and we have been invested in ML and MLOps getting machine learning models into our IoT connected products, which is the Otis One product, which we announced in 2018, with the principles of being proactive, predictive, and transparent. That's our bedrock for that program. ML, we have deployed different kinds of models. We have our standard supervised ML learning models. We have rules-based models. We have usage-based models, and a lot more other advanced analytics. So these are the models that we currently have in production and which we are constantly working and trying to get better at. We have a wonderful analytics group that is constantly coming up with new models and validating those models, and those validated models go into production as and when required. Our ultimate goal is probably to have a model for each elevator and be able to run it for each elevator, because in each elevator, the usage might be different from somebody else. Because we have many different versions of elevators, it just makes it easier to predict if an elevator is going to have a problem or not, or whatever else that needs to be. So having said that, it really creates a need to have a really good MLOps process. Because if you end up right now we have about 3 or 4 different kinds of models and rules running, which is manageable. But if we end up having 20, 30, 100 different models, unless we have a solid ops process in place, managing that will become near impossible. So we started working with our analytics team, which develops the model, and then try and get our DevOps team involved to do the operations, run the models, manage the models, monitor the models, and see if we have to switch the models, what do we do? All that processes we have to start building. So this is where we are, and we are still learning. We're a few years into this journey, and to me, we are nowhere near perfection yet, but we are very good at what we're doing. So it's getting there.
Wow, that's really interesting. Yeah, different models for each different elevator type, and having to put all of that into production. The scale of that, there's no way that you could do that manually, and you would need a team, to help with that. Really interesting.
Right, it's a process, and we're not there right now. But if we do get there, we better have a really good MLOps process.
Right. Yeah, I completely agree. How about Ankita? What's happening at the bank in terms of what kinds of models you're putting into production and what drove the need for MLOps?
Let me stop. I think Ankita might be on mute. Ankita, we're not hearing you clearly yet.
Well, why don't we ask, I can ask Shiva what's happening at LTI, and what he's seeing with his customers and how that's all working, and the kinds of models that they're putting into production, and what you're seeing, through LTI about the need for MLOps.
Okay. So I think we're very fortunate enough that we got a chance to work with so many different types of industries, and a couple of industries I want to discuss today. So one of the recent examples we did with one of the large oil well company. So what they were trying to do was they had a lot of assets that they'd created. They had around 12 million documents or 12 million images of various oil wells they had created. So seismic images and the oil log wells and a lot of different types of curated images by their petrochemical engineers they had collected over like last 80, 90 years. So I think one of the challenges was to digitize all of those assets. Digitize everything into one single platform where people can come in and they can search through the images and get through what this image is about and stuff like that. when they started off their journey, I mean, they were mostly got some few engineers to annotate those images, and they kind of manually started building that whole annotation approach. But with 12 million, 12 million documents that were available there, and then manually annotating them was very time consuming. I think that's where we jumped in, and we try to see how if machine learning can help build that fast track that whole approach. It's pretty. I mean, we were pretty successful in doing that. I mean, we trained this model wherein it can identify which type of image it is, and then from there we try to identify, doing the OCR, identify what is the location of this image, where it is being taken, and where exactly is the graph located, what is the latitude, longitude of this. So we try to extract all these things and try to annotate the whole image, and then before digitizing it, all the annotation is kind of powered by the ML algorithms. It was a very interesting thing because it involved the whole MLOps approach, wherein we had this data and we had a team of annotators, more like a human in the loop, who were trying to annotate this image, and then there's a machine learning algorithm which is trying to learn from all these things. And then we used to have a newer version of the model deployed, and then again, the human in the loop will give more and more training labels for us to train back, and then we kind of create a new version. And this whole life cycle of this model was pretty much all orchestrated there. So that's one of the, I think, not so well-known industry. I mean, oil industry, I think it's a very, very far off, and doing such a machine. I mean, they're so much into doing all this machine learning, and they were so excited doing this. I think that's one thing that I see is a very good example. I mean, finally, we kind of got down around 30 to 40% of the manual efforts through the machine learning intervention. And one more typical example, I think we're working with one of the, service companies which is trying to use the, machine learning to increase the, customer engagement, or probably better, how do we engage with customers better? So what they were trying to do was trying to mine all the customer interaction, like whatever they put it on Twitter or any mail that's coming to them through the service channel and everything. So they used to harness that and understand what type of message is it. I mean, is it a query, or is it a suggestion? Is it a complaint? And if it's a complaint, who should be the one inside the company who should be the responding to that? And that's where, they kind of introduce this whole ML to help better engage with the customers and to have a better SLA to respond to the customers. And there are many such examples where we're trying to help the customers. And one thing which clearly came out while doing all these exercises was that in any large enterprises, there are so many different teams working together. I mean, it's like every single data science team or every other unit has their own way of developing the model. I mean, some might be using Python, some are using R, and some using Spark, and so many different languages and different tools to build the models. And that's where whenever they want to make it to a production like environment, so there was a lot of gaps between how the way the models are developed and the gaps between how the model should be deployed. I think that's one of the primary reasons why this whole MLOps as a concept is coming up, wherein how to seamlessly integrate everything so that teams have an flexibility to develop their algorithms the way they do. But finally, the MLOps should be capable of handling every such algorithm and kind of provide an unified serving interface for all of those. I mean, that's where I think we see that MLOps is being emerging as one of the field.
Yeah, that makes a lot of sense. Yeah, because people are developing models using different tools, and then, how do you get that all out into production? That's another good MLOps reason for MLOps. Let's see if Ankita, if you're back, and if you want to take a stab at this question.
Are you able to hear me?
Yes.
Okay, finally, I'm glad. Okay, so let me put a perspective on a financial industry on this question. So the rise of machine learning usage in financial industries has now long been discussed, and definitely there are evidences and case studies coming up that is already promising a new way of delivering successful outcomes and solutions. And being in the financial industry and being associated with it for long, I have seen that the machine learning is largely used in two areas. One is, of course, gauging your risk assessment, and then fraud prevention. So how fraud prevention? We use forecasting using machine learning algorithms, which allows the organizations to monitor transaction parameters in real time. And hence, these algorithms, what they do is they examine and evaluate customer actions and other variables to determine how likely a suspicious transaction is to be fraudulent. Coming to the risk assessment, the machine learning is primarily used in the area of model risk. So what is model risk? Model risk in a layman term is a potential loss that may occur as a consequence of misinterpretation of the output of a model, which could be induced due to development or implementation or lack of adequate processes in place. Now, of course, model risk has its repercussion, and inaccurately setting up processes for model risk can lead to financial loss, poor business and strategic decision making, and hence a damage to a financial organization's reputation. So how a scenario on how machine learning can be used in model risk. So in credit scoring, right, traditional scorecards are developed using numerous variables, which are nothing but your features. So when a consumer asks for a loan, right, the credit institution has to make a decision on whether or not to grant it. However, it is very likely that the decision will be informed by scores that estimate the probability that the loan will or will not be repaid or expected. It's based on the customer's profile, whether the customer has repaid the loan in the past, he has the adequate financial status, his employment status, and all that. And of course, during the pandemic, many of these variables have changed drastically. The way model risk is being calibrated in the bank right now is being discussed. It's going through a complete revamp, and it's in any financial organization. So the need, therefore, to recalibrate our models post-pandemic there is a big need of it, and a speedy response to the regulator ask is definitely inevitable. Now, how machine learning is coming to a rescue is, as we said, that machine learning gives you a whole setup wherein at bulk the models which have a similar algorithm can be implemented. Hence, it saves a lot of time for the modelers, the data scientists who are working on those models. Yeah, so definitely we can see that the future is here, but we are now reaching like a critical juncture where business really needs to realize and prioritize the machine learning capabilities and reap the benefits that kind of come out of it. When done right, of course, we are kind of realizing that MLOps, which is machine learning operations, enables a much more systematic and sophisticated way of deploying and automating the models in production system, and hence a faster time to market for the bank's risk assessment. Yeah, so needless to say, MLOps brings about agility and speed. That is the cornerstone in today's digital world, definitely.
Yeah, that makes a lot of sense. So all good examples of, the kinds of models, that are being built, and good reasons for MLOps, whether it's trying to, have so many models, that you need to have MLOps, being able to get faster time to market and all of that. So let's move on to the next question. So, I talked about when I showed MLOps on the machine learning lifecycle, I talked about versioning and registration and monitoring and retraining, and, there should be metrics and, these sorts of things. What are the feature functionalities that your organization is looking for in an MLOps offering? I mean, we know MLOps, has both people, processes, and technology, but if, on the technology side, Ankita, let's start with you. What are the features and functionalities that your organization would look for in an MLOps offering?
Yeah, sure. Again, coming from a banking domain, the MLOps as a term is not just restricted to a system. There is a lot of discussion on what the regulators want and what are the guidelines that as an organization, any financial organization needs to put in. So we all acknowledge that the growing use of AI presents opportunities. But the regulators do realize that this also provides new risk management challenges to the banks. But having said that, regulators are becoming interested in and supportive of the use of AI/ML RegTech solutions. While the risk of AI/ML models are qualitatively similar to those of traditional models, the reliance on high-dimensional data, dynamic retraining, and the opacity of the logic, which kind of is inbuilt in the algorithms that runs at the back end, can lead to kind of unexpected results, and I would say a not trustworthy result. So first of all, as an organization, we need to set up a guidelines for us that what is a reasonable AI/ML for us, and how do we justify the output that will come out of the AI/ML algorithms and models. So in November 2018, actually MAS, which is the Monetary Authority of Singapore, has released a set of principles to promote fairness, ethics, accountability, and transparency in the use of artificial intelligence, which is called FEAT. Very famously, it's called FEAT principles. So FEAT is all about, justification of the output that has come from the ML models. Accuracy and biasness, right? The financial firm should regularly review their data-driven decisions so that models behave as designed and intended can be explained, right? And then ethics. We should ensure that the output that the ML models are giving, they are aligning to the firm's ethical standards, values, and codes and conduct. Then, of course, accountability. When we say accountability, this is a very important term that currently is getting coined up with the usage of AI/ML models, wherein we say that any AI firm should ensure that there's both internal and external accountability of the decisions made from the usage of ML models and algorithms. Essentially, there has to be a proper internal authority that approves the usage of these models. And then also there has to be an external authority, and regulators are being made aware of our strategies on how we are churning out the data of these models, which is being submitted to the regulators. And of course, needless to say, transparency. Right now, today, we see that the systems that are coming up in the market, which offer these ML capabilities, there is an element of transparency, which is the explainability, which is missing. Essentially, they run algorithms, but they don't explain how this output has been generated, what the features that have gone in, how those features were calibrated to get that output. So I think that transparency is something that is being discussed, and that is where, one of the features we are looking in the technology platforms as well that we come up. Now, talking about the platforms from a system perspective, what we see is the MLOps platform should automate processes for ensuring that the models are built, developed, validated properly on a platform, and there is a proper governance setup in accordance to the ICS and CISO principles of the bank. Of course, needless to say, DevOps process is the backbone of any MLOps process, wherein the DevOps process has to be automated using the CI/CD framework, which can build, test, and deploy software. So essentially, we are saying that a platform which kind of integrates the various model life cycles using ML, using DevOps, and enabling data scientists to churn out a meaningful model output is something that we are looking at in a MLOps platform and service.
Oh, really interesting. So is that multiple? Are you looking at it seems like maybe there's more than one sort of service and platform that you might have to use to do everything that you need to do.
But yeah, I mean, it needs to be integrated in the platform. That should be the power of MLOps platform. MLOps should be integrated with DevOps, should be integrated with the data pipelining that is to be used by data scientists. Yeah.
Yeah, that all makes sense. Yeah, when we talk to a lot of data scientists, we say, what do you need more of? And they say, we need data engineers and better pipelines. So
yeah.
That's a whole nother conversation. Sanjit, how about you? What are the features and functionalities you're looking for in an MLOps, offering? Do we lose Sanjit? But we can ask Shiva.
I apologize.
You're there.
I didn't realize I was muted. For the MLOps itself, what we really look forward in an offering is performance, scalability, interoperability, or flexibility. So you can run different kinds of models and different kinds of outputs and manage those things and then do operations on the outputs of the models. I'm not addressing how to build a model because we have a whole different group that actually builds the models. From the pure ML ops point of view, we would look for a platform that we can execute multi-models. Like, for example, in an elevator, we have multiple elevator systems. We may have 8 to 9 different sensors in an elevator, or maybe more, depending on the kinds of elevator. And each of those sensors might have a model that execute for that sensor, apart from a general elevator health models and things like that. So now you're running 6, 7, 8 different models for one type of elevator, and this is just an example, right? So you want to have a system that allows you to run multiple models at a time and be extremely reliable, because you don't want one model to break. You want all of them to run. You want all of them to run all the time when you want it, when you expect it to run. So typically for us, reliability is extremely important. Our processes of DevOps and CI/CD, we have that handled, right? So that's integration to our CI/CD is very important too, because we don't want to create a whole new process just to handle ML models. Because our DevOps teams, when they talk to our development teams, we want to talk the same language. We want to have a single stream that goes through all our DevOps processes. So that integrations have to happen. The ability to integrate various different platforms, because some of our models might be developed in Python, some may be using a separate tool, some may be using a Microsoft tool, some may be using AWS, whatever it is. It shouldn't matter. From an ML ops platform point of view, we should be able to integrate anything, anywhere, and be able to execute it in a seamless manner. That is what we look for.
No, that's really interesting. And it seems like it's a journey, right? Like you're not, are you there yet?
No, not yet. It's a journey. It's a journey. It'll take some time, and our DevOps processes are in a very good, robust place. Our model development is in a great place. Now we work very well together, and we have a good understanding of how things move. And we use LTI's Mosaic platform to bring things together. But it's a journey. There are always things that can be improved. There are always things we look to make better. And again, right now, as I said, we have only a few different kinds of models that we run. But at some point in the future, we might have hundreds of models. So we have to be able to put in place systems that can handle that. It might be a year out, 2 years out, 6 months out, whatever it is, whatever the time frame is. The principles of ML ops that we put in place now is going to serve us down the line, and it has to serve us well.
Yeah, that's very important. That's an important point that you make, that you're planning for the future also. That's good to know. Shiva, how about from the LTI perspective? Can you tell us about some of the feature functionality in your offering?
Hey, thanks, Fern. I think thanks, Ankita and Sanjit. You kind of explained how the overall MLOps platform should look like. I think we have been on this journey of developing this platform, which can ease out the whole MLOps journey. Right? So we already talked about the model development part. So probably will not go into how the model should be developed. I mean, also there is one piece of our tool which helps you to do that. I mean, it can help you connect to the various data sources, get that, prep the data, and build the models in various containerized environment. But today we're going to talk about how our tool helps to manage the models, right? So if you see, there are 4 different things we think is very important for the model management. The first thing is of course the deployment part, right? I mean, let's say I created a model, and how do we deploy this model so that it can be used by all the different applications inside an enterprise. So, I mean, we see that a lot of companies or enterprises are doing this whole deployment manually. I mean, in the case of there is a team involved who is creating a wrapper, and sometimes it might also happen that people kind of rewrite everything into some other languages or frameworks just because to attain the scale and that is required for the deployed models. But that is, I mean, it's very slow in process. I mean, if you go with the manual deployment approach, and it's really slow, and you kind of late to achieve your returns of investment on the AI journey. So I think the first offering that we have is the complete automated deployment. Be it any kind of model, you just have to push those models to us, and we'll take care of deploying those and creating an API on top of that, which is kind of scalable and stuff like that. Right? I think that's the first thing we see. The second part is which is very important. I mean, I think how do we monitor these models? I mean, as we all know that we have been using all the software applications over the years, and I mean, monitoring a software application is fairly simple. I mean, we kind of monitor what is the resource usage, or what is the logs that are coming out of the software application, and are there any ups and downs of the application. So I mean, we already know what to monitor for a software application, but models are a bit above that, right? I mean, let's say you also have to monitor all these things, the technical things like logs and usage and everything. But apart from that, you can also have to monitor more around how my model is performing. I mean, like, models are mostly probabilistic in nature. I mean, they may change based on the input data might change, or the model can start getting a lot of outlier data, and the model performance might degrade. I mean, let's say I might have created my model. I mean, data scientists might come and tell me, okay, when I trained this model was like giving some X percentage of accuracy, but when I really put that into production, we come to that when the real production data starts getting into that model, the performance might vary based on what segment of data I was taking while I was training my model. So I think measuring that model performance, I think, is one of the very important thing, and our platform helps you to collect the ground truth and start churning out all these dashboards for you, which can tell you how my model performance is varying over time. And the third thing, I mean, once we have this model performance gathered, and we kind of, let's see, start getting alert, something like this model is deteriorating or it's not working properly, we might want to retrain this model and create a newer version of this, right? And that creates one more level of complexion, that how do we kind of have multiple model versions available there, and how do we kind of roll out those models in a more sophisticated manner that I don't want to, I just want to roll out as an A/B testing, or I want to do it as a more like a I mean, it's a restricted rollout to some of the users and stuff like that. That's, I think, the whole model rollout strategies, which is very important for you to have one version in production and one in a shadow or on A/B testing, and then compare the performance before rolling it out completely to the entire team. I think that's the third part on the how do we kind of manage the model rollouts and everything, right? And the final thing, I mean, you kind of deploy the model, you have the monitoring that, and you can have the rollout strategies defined. But you should have a proper governance structure in place. Governance in the sense the models should be, I think, you should have all the security, access control, and all the rollback needed for that, right? I mean, who should use this, who shouldn't be using this, and how do we manage this RBACs and everything? That's one of the core things on the governance part. And also one thing which is we have seen is very, very useful is kind of an model catalog. Model catalog in the sense, let's say, in a company, it might happen that a lot of people might be working on a similar use case. I mean, they are so big an enterprise. I mean, two different teams might be developing a similar application. So I think it is very important for someone to have a centralized model catalog or a model view wherein you can see what type of models were created by other team, and if they can browse through that and see, okay, this model might be useful for me. So that rather than I reinventing everything, so shall I just go ahead and start using it in my application? So I think that whole model catalog or a centralized model view is something which is part of the governance thing. So just to reiterate, right? I mean, there are four things: one on the deployment, the second thing on the model monitoring, the third thing on the multiple model rollouts, and finally the governance steps. These are the four pillars, I think, which is needed. Of course, I think, Of course, I think the next part of the journey would be to provide how do we kind of explain the model. Probably, and that's one thing which Ankita talked about, how to, that is one of the very important thing which is needed for these more regulatory based companies. Not also regulatory, but also for any company which have started using. I think as a human, we are very curious about to know what's happening behind the scene. I think that is something which is needed. And of course, I think one more area of thing that people also started to misuse the models. I think people are trying to push some data to the models which can change the model behavior altogether. That I think, how do we prevent that model attacks and everything? That could be the next step for us to go into.
Yeah, all of that. Well, I hope people were taking notes because there are a lot of really important features and functionalities that all three of you mentioned. And certainly TDWI, we're talking a lot more and trying to get people to think about issues around model governance and how to support model governance to the last point that you made, and explainability, ethics, the multi-model, all of those things are just so important. So that sort of talks about the technology. What about like on the team side of it? You know, how did you all set up a team? Or I should say, Sanjit and Ankita, you know, how did you set up your team to support MLOps? Let's start with Sanjit. How did you set up a team to support MLOps?
That's a very, very, very interesting question. Very good question. Well, it all starts with having a good data scientist. If you don't have a good data scientist, and I'm not talking about model development, right? Model development, there obviously are really good data scientists. But from a model MLOps perspective, you need a data engineer or data scientist, a data analytics guy who can actually go through and look at the model that you have deployed, go through the data, go through the data that's needed for execution, and make sure that the data is right. It actually conforms to what the model needs, because over time, and we all know this, over time, data can change. And if you're using 10 different parameters of feature engineers, engineered features, and then things start changing. Now the model's precision and recall changes. And if the model's precision and recall changes, now it's really it's not doing its job, right? So you need somebody to take a look at it and say, okay, yeah, this is good, this is good, this is good. At the same time, you also need to have a solid DevOps team that understands, the entire DevOps cycle, entire DevOps pipeline. It knows where the data pipeline comes in, how the model gets plugged in, how do you execute it, what do you expect when the model executes, and where does that data from the execution of the model, the results, where does it go, how is it presented, whether it goes into a repository, whether it goes into a warehouse and APIs are pulled out, or whatever else it is, right? That entire DevOps process and how it also connects to your CI/CD. These are very important. So when you start building a team, you start with the data engineer, data analytics guy, or the data scientist, no matter what you call them. Then you need a solid DevOps engineer, right? And then you really need to pair them with somebody who understands CI/CD. And we use Agile a lot, so we need an Agilist in the team so that they understand how the whole Agile process works. You don't have to have a large team, but you need to have very competent people in the team, and you have to have some key positions filled. How we started, right? And we now have a good team. Our team is very dedicated, very sharp guys. I mean, they can run circles around me about all the processes that we use. And this is a bare minimum at this point, right? And you can add to it afterwards on top of it, have an overview guy, have a governance guy, and all these things. But this is the bare minimum you need.
Yeah, it makes sense. Ankita, how about from your perspective? How did your organization set up its MLOps team?
Yeah, sure. I mean, it's interesting to know different industries, different domains, but the foundation of teams is almost very similar. I think for a financial industry, an MLOps team would essentially consist of three pillars: data scientist, DevOps or model ops, and ITO ops. Data scientists, like as Sanjit mentioned, data scientists are the kind of people who know about the features, who know all about data, who can know what input goes to a model. And if a machine learning model runs, the output that it generates, they are able to verify that output. DevOps or model ops, of course, are the people who have a very good understanding of the DevOps tools like Git, Bitbucket, Jenkins. They have a command on automation technologies and tools. They have got software security skills as well, and a basic coding and scripting skills around Python, Java, or Bash, Shell. So these languages. And of course, what is ITO ops? So ITO ops is essentially the people who are deploying or are responsible for maintaining the stability of the production systems. So especially in banking organizations, there are a lot of restrictions and security and governance on the production system. And from a role standpoint, a person who is from a development arena cannot access a production system. Hence, there is a specific team that specially manages the deployments into production systems. And that team is called ITO ops. So yes, definitely ITO ops is much needed to kind of encapsulate all these things in an ecosystem. And when we go on to the how do we run any project which needs machine learning, I think the best way to run the project is using the agile methodology. Because as we know, agile methodology is the process of continuous feedback and continuous improvisation. I think it just gels with the motive of using machine learning, implementation for the models, because it of course mitigates the risk of last minute surprises, and early feedbacks becomes a common practice in running any agile project. And the third theme would be the oversight of the output of the AI ML models, oversight by the board, by the senior management, by the businesses who are meant to do the UAT. They should be very much aware of what the output should produce and what are the acceptance criteria for the models that are churning out outputs. And they are very well aware of the effectiveness of governance and controls that are used in the AI ML model lifecycle. So I think for us, these are the three themes that any banking organization should kind of work on in order to set up a very efficient MLOps ecosystem.
Yeah, very interesting to hear from both of you, one on the regulated side, one on, a different type of unregulated side. The kinds of people, there's a lot of overlap. And, what's really needed for MLOps. Shiva, what are you seeing among your customer base, and, how can technologies be leveraged by the MLOps teams to help them scale?
Yeah, I think so. Pretty much, I think the similar structure is kind of emerging across all the industries. I mean, three different streams coming together: a team of data scientists who are building and creating the data and managing and developing the models, and a team of ML engineers. I mean, we call it, currently the ML engineering is a word which is being associated, who are very good with creating this, taking this model out, taking a wrapper out of it, and creating the pipeline and deploying them. And I think the third pillar of the thing is the whole IT operations, or the IT infra people who are supporting the infrastructure, who is monitoring the infra, and are kind of helping the both of these teams. So we think this is the intersection of these three streams coming together is where the MLOps is originating.
Yeah, makes sense. I want to leave some time for audience Q&A. So Brenda, I'm going to turn it back over to you, so at least we can take one or two audience questions.
Okay, that sounds great. Yeah, lots of great information there. So let's go ahead and grab a question that often comes up. And that question is, someone is asking, can data scientists be the MLOps team? And why don't we start out with having Sanjit answer that, and then the others can weigh in on that as well?
That's a wonderful question. Can data scientists be the MLOps team? Can they be? Sure. But just because they can be doesn't mean they should be. Ideally, a data scientist's job should be to build new models. Earlier, a little while ago, I said, how we build our ML ops. I said, yeah, I have a data engineer. Well, I don't necessarily need a data scientist. I need a data engineer to understand the data. I need a guy who can do data analysis, so they can check that the engineered feature engineers, engineered features, all the input data is right, the output data looks right. They need to look at and make sure that the model did not get stale and things like that. Ideally, I wouldn't want data scientists to waste their brain cells on being on the ML ops team. Not that being an ML ops team is any less stringent or harder to do or less harder to do or anything of that sort. It's just that their particular skills are better used in building models and not necessarily executing models. That's my take. Anyway, it's a personal take. It's not necessarily agreed by everybody, but that's just a personal take.
Yeah, I mean,
do you have anything that?
Yeah, I think data scientist becoming and merging into the MLOps team is the end game for us, right? The day data scientists start to realize the skills that are needed for MLOps, and they start to realize that joining hands with the MLOps processes would expedite their process further, I think that's the day we have reached nirvana for machine learning. So, yeah, I think, yes, definitely an idealistic situation, but are we there? No, definitely not. We are there. No. And we are working towards it. Yeah.
Thanks. Shiva, do you have anything to add to that?
No, I think absolutely. I mean, so the skills are a little different. I mean, the data scientists are more towards the business side, who already are doing a lot of things like understanding the businesses and understanding the data and creating the models and all those things. And the MLOps team, I mean, the deployment is more of a very engineering type of a skill. So of course, a person can have both the skills, but it is very important. I mean, it's very good to have two different set of teams, one data scientist and one ML engineer who is more on the software engineering principles, and he can go deep into that, and a data scientist can concentrate only on building his model, and they can come together to provide a integrated view for the users.
Makes sense. Well, I wish we had time. We have more audience questions, but unfortunately, we've come to the end of our time. There was a lot of great information covered. So let me take a quick moment to thank our speakers today. Today, we heard from Fern Halper with TDWI. We heard from Shivanand Pawar with LTI, and Ankita Gupta with Standard Chartered Bank, and Sanjithraj Rao with Otis. Also, thank you again to LTI for sponsoring today's webinar. Please remember that we did record the webinar, and we'll be emailing you a link to an archived version of the presentation. Feel free to share that with colleagues. And also, if you'd like a copy of today's presentation, you can use the click here to receive a PDF. Finally, I want to remind you that TDWI offers a wealth of information, including the latest research, reports, and webinars about BI, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. So from all of us here today, let me say thank you very, very much for attending, and this does conclude today's event.
Hey, thank you.